Hey guys, welcome back to Knowledge Bites for CS. We shall continue where we left off. Last time we did the introduction and the basic format of the papers. Today we will start with a topic. Topic 2, Computer Organizations for CS Paper 1. Before we get started, these are some key terminologies you will need to know, or key abbreviations about CPU, ALU, CU, MAR, MDR, RAM, ROM, and OS. These are important abbreviators which you need to know. Now let's get started. What is a CPU? CPU is a key component of the computer system. It's like the brains of the computer. Without the brains, the computer is useless. ALU is in the CPU. ALU is in the CPU. ALU, or as we did over here, arithmetic and logic unit, does arithmetic, addition, subtraction, and logic, and or the Boolean operators, calculations. Basically, it does anything which requires some calculations. Sometimes ALU is referred to as a core. So if you have a dual core computer, you have two ALUs. The more ALUs, the faster it will run, because there can be two calculations performed at the same time. CU handles the loading of new commands into the CPU. So basically it's like the brains of the brains. CU tells CPU when to decode, what to further give instructions to its other parts. So CU is like the neurons in the brain. CPU is the brain, then CU is the neurons in the brain. It handles all the loading of the instructions, the sequencing also. It also directs data flow and the operation of ALU. This is the computer architecture. This is a very important diagram. I suggest you learn it by heart, because all the recent exams for CS paper 1 which I have seen has this diagram in some form. So basically what we need is to the right hand side and to the left hand side. To the left hand side is everything within the CPU, such as the CU, MDR, MAR, ALU. Again, MDR is memory data register and MAR is memory address register. So I would suggest that you memorize this diagram by heart, because I can guarantee it is going to be coming in some form in the exam. And that's to the left. To the right is RAM, or the primary memory, random access memory. RAM is random access memory. RAM. Usually, if it's not stated and if it's just stated memory, usually memory will refer to RAM. This is the machine cycle. Basically takes us through the steps. Step 1, fetch the instruction from memory, main memory, or as I said, main memory, primary memory. All these are fancy terms, but they all almost always mean RAM, or random access memory. So this is the machine cycle, where it fetches the instruction from main memory, decodes the instruction into commands. The CU decodes the instruction. The ALU executes the command given by the CU if there is arithmetic involved. So it executes the command, and after that it stores the result in the main memory, or RAM. This is kind of an important cycle, I would say. So basically it's main memory, CU, and then ALU, and then back to main memory again. This is registers. Programs are loaded from the storage into RAM, or the main memory, and are executed on time by the CPU. CPU needs its own memory. Its memory is called registers. Registers are small, fast circuits that store intermediate values from calculations or instructions. That means you have some calculation, you store that value in the register, you perform another calculation and that previous result you needed, then you use it. So that's what intermediate values means. There are many registers, but the two most important ones are MAR and MDR. MAR, over here again we go. MAR is memory address register, MDR is memory data register. MAR and MDR are inside the CPU, connected by the address bus, which is bidirectional, so that means it only goes in one direction. And MDR, it catches the data bus. Data bus is bidirectional, so it can take information as well as give information. And CU hops on the control bus, which again is only unidirectional, not bidirectional. Now the MAR and MDR. MAR is memory address register. It connects to the address bus, contains the memory of the address. MAR's sole function is to contain the RAM address of the instruction in the CPU wants, that the CPU wants. So MAR's only function is to contain the memory address where it is stored in the memory, because RAM is quite big and slow. So it MAR, instead of every time the CPU having to check through all the memory, MAR consists just of the address where the memory is stored. MDR, or memory data register, is connected to the data bus. MDR holds the data that will be written to the RAM or will be read from the RAM. That's why over here data bus is bidirectional. It can read and it can also write. Relationship between MAR and MDR. The MAR gives the address where the data is stored to the MDR, and MDR will read or write the data in that particular place. If it's read, then MDR will read the data from that place and then give it to CU for further processing. Buses. See, over here we said data bus, address bus, and over here we said control bus also. What are buses? So buses are connecting wires that connect the CPU to other devices carrying instructions to and from components. They are normally built into the motherboard. Three most important buses are data bus, control bus, and memory bus. Data bus links RAM to the CPU via the memory MDR. Control bus links RAM to the CPU via the CU, and memory bus links RAM to CPU via MAR. MAR is memory address register, MDR is memory data register. That's why data register, data bus, address register, memory bus. And again, this is what I said over here. CU is the control bus. MAR, memory address register, is the address bus, only goes to the RAM, cannot get instructions back from the RAM. MDR, memory data register, can go to the RAM and back also. It can read and write. Inside the CPU, this is another way to put it. ALU, arithmetical logical unit. Other registers: MAR, MDR, CU, address bus, data bus, control bus. Main memory is basically RAM, random access memory. Memory. Now, memory, there are two types: primary memory and secondary memory. Primary memory basically is what we think of the memory. When we think of memory to store stuff, it's the primary memory. Secondary memory, anything you plug in, such as the USB, SSD, hard drive, flash drive, anything. Typically, it's magnetic, optical, or electronic. Now, primary memory includes RAM, ROM, and cache. Now, RAM over here is random access memory, and ROM is read-only memory. Now, there is a very distinct difference between RAM and ROM. RAM can read the memory and write the memory. ROM can only read the memory. Read only memory, ROM, read only. It can only read. while RAM is random access. It can access anything in the memory. That's why once the question asks what is RAM, the difference between RAM and ROM, we will talk about it later. Also, it involves cache or cache, however you would like to pronounce it. Basically, a type of memory before RAM. We will explain the difference between RAM, ROM, and cache in the next slide. Now, primary memory is RAM. As RAM is so important, it is often referred to as primary memory. It's actually a branch of the primary memory alongside cache and ROM. Yeah, this is what I said. Unless explicitly stated otherwise, it would normally be referring to RAM. So anywhere it says primary memory, it is equal to RAM, and RAM is RAM is random access memory. So memory which can be accessed from anywhere, anytime, random access memory. Suppose I want to open a file. The file is stored in RAM. Anything you create or you do anything, it is stored in the RAM, random access memory. Now RAM is random access memory, contains the data and instructions the computer has loaded since starting up and everything the user has opened or loaded. This is what I mean. Anything that we put in, the user, we have loaded since the starting up, it was RAM, is volatile. This is one of the important points, the difference between RAM and ROM. RAM is volatile. That means if it loses power, all the contents in RAM are lost. All the contents in RAM will be lost, yes. That is one of the key differences. Also, RAM has a special link to the CPU via buses. Now, ROM, read-only memory. As I said, it's read-only, so it's static. You cannot change the contents of this memory. That's why it's read-only. That's what I said. And could not be changed. We can do flash upgrades, but we don't say that in the exam. So usually ROM, you cannot like update it, but now it's not true anymore. This is the main difference. Non-volatile, does not lose its contents if power is lost. Also, it stores the BIOS, basic input output system. It basically tells the program, tells the computer how to boot itself, computer or operating system, how to boot itself after the power is restored. So that, I think so, is the main difference between RAM and ROM. Yeah, here. Difference of RAM and ROM. RAM is volatile. That means if power is lost, all the data in RAM will be gone. We can say like that. ROM, however, is non-volatile. RAM contains the user's programs and the data that has been uploaded since booting up or starting. But ROM contains the BIOS, the basic input output system. And RAM, usually upgradable, can be increased also, like the 64 GB, 32 GB, 12, 8, 7. ROM is usually part of the motherboard and it's difficult to upgrade. But one way is to flash upgrade. But we usually, for the exam purposes, ROM we cannot upgrade. So this is what the difference is. That if power goes off, RAM, all the data in RAM will go off also. But the data in ROM will not. ROM is non-volatile. This is what RAM and ROM look like in the computer. ROM is part of the motherboard. So this will be one piece in the motherboard. RAM, you have like the chits which you can install. So that's how you upgrade the RAM with this. Now cache. Cache is a cache or cache. It's basically a small high-speed memory inside the CPU. So over here I said CPU needs its own memory. Yeah, CPU needs its own memory. So it's usually inside or not in the main memory or RAM, but it's could be inside the CPU, could not be inside the CPU also. Its main use of RAM cache is to hold frequently used data, so the CPU does not need to access the much slower RAM less frequently, because RAM is a large data, like you have to go through a large amount of data. So cache is basically like the frequently used data, you keep it before the RAM. It actually exists in levels or stages in modern computers. This is an example of a single cache of 3-level caches. Each one you go away, it becomes slower. The closer it is, the faster it is. This is what you can have: a primary cache inside the CPU or outside the CPU. This is what I mean. The closer to CPU you are in the cache, the faster it is to retrieve it, because it's just right there. However, it cannot be very large amount of storage. It cannot have a large amount of storage because cache needs to be small so it can be accessed faster. That's why main memory or RAM, that's why it's written over here, the size increases. So the amount of data, the further from the CPU, the main memory, the data will increase. That's why over here you can also see CPU is here, cache is here, and then the main memory is much bigger than the cache. The same here, CPU is over there, level 1, level 2, level 3, and then the main memory is so big. This chart shows the relationship between size, speed, and cost of various devices. Like CPU registers, it's very fast, but it is very expensive as it is part of the CPU. And because it's part of the CPU and CPU is very small, so size also is very small. Then we have cache, which is fast, 10 nanoseconds. It's an expensive $150 for a megabyte, and it's small also. Then you can see RAM, hard disk, offline storage, tapes, drivers, etc. In seconds also it's very slow, but because it's slow, it can have a huge amount of storage, petabytes. Usually like companies like Google and Apple, the very huge tech companies, Facebook and all, they will have these offline storage devices. They are slow, but they will be like regularly backed up, because they are so huge and like slow, they are least expensive. So this chart is not that required, but it will give you some idea that suppose we are talking about RAM. RAM is fast, yes, it's fast, but it's also pretty large. So the cost will also be not the most expensive like the CPU, not the least expensive also like the offline storage devices. Now, the machine instruction cycle, or the fetch, decode, execute cycle, and store, or the FDX cycle, is the basic operations of a computer called fetch, execute cycle, machine cycle, where the computer fetches the instructions from its memory or RAM and then executes it. This is done repeatedly from when the computer is booted up to when it's shut down. This is the steps of the fetch, decode, execute cycle. So basically you fetch the instruction, then you decode the instruction, and then you execute the instruction. That's the basicness of the fetch, decode, execute cycle. Yeah, usually like over here it's stated, fetching the instructions is the first thing. The CPU fetches it from the main memory, RAM, and then stores it on the temporary memory called the registers. Then it's on the registers. Then next is decoding. The CPU will need to understand the instruction with what it has to act with the information from the fetching. This is called decoding. And then the CPU has understood what to do with the data. It has the data, and then it does what you want with the data. That's called execution of the instruction set. Note, usually in the exams, they want you to describe the role of the data and address buses in the cycle. They also want you to think about what information they carry from where to where and then how they connect to each other. That is what I was referring to over here. This computer architecture, this picture, you need to really ingrain it in the mind. The ALU, what's the function of ALU? What's the function of MAR, MDR, CU? What's CPU? What's cache, what's RAM, ROM, difference between them? What's the address bus, data bus, control bus? Usually they don't ask about the other registers, usually just about MAR, MDR, CU and all. Like what's the function of ALU? What does ALU do? ALU is the arithmetic and logical unit. So it does the arithmetic, the +1 and the -1, and logic, the and or the Boolean operators. So ALU does the logical stuff. CU controls the CPU. It's the control unit in the name only. It's controlling the actions of the CPU. Memory address register, MAR. It gets the address from the memory or the RAM. Data, MDR. It collects the data from the address provided by the MAR. So MAR is by the address bus. MDR is by the data bus. CU has its own bus called the control bus. So like that. Mainly just the definitions of it, what's the functions, and for the memory, what's the difference between the primary memory and the secondary memory. Primary memory usually already comes installed in the computer. Secondary memory, as I said over here, you have to plug it in. Yes, so anything you plug in, such as a USB, hard drive, SSD, solid state disk, flash drive, etc., anything you plug in, it's the secondary memory. In the primary memory, they can also ask the difference between RAM, ROM and cache, which is written here. The difference between RAM and ROM. ROM contains the BIOS, RAM contains the user's information about the programs which they are visiting. RAM is volatile, ROM is not volatile. ROM is usually part of the motherboard and it's difficult to upgrade. RAM is upgradable. RAM is these chips over here, so you can get more of these chips put. Usually like RAM has like 6 GB, 8 GB, 12 GB, 64, 32, 128, 256. We have many options about the RAM, but ROM, it already comes pre-installed on the motherboard, so it's pretty difficult to upgrade the ROM. So usually that's how questions come from the IB, that as I said before, all those questions, usually those type of questions come defining and the difference between each. So that's all for this video, guys. This was computer architecture. This was computer organization part 1. I shall meet you in computer organization part 2. This was a 2-part video and I shall see you then. I hope this was interesting.